This chapter deals with the profit maximization problem of the representative firm and the factor rewards that emerge from this profit maximization problem. First of all, I'd like to clarify what the representative firm actually is. And here in the basic models of macroeconomics, we typically have the situation that there are many very small firms that produce a homogeneous good. And that means that the actions of one such very small firm do not affect the market prices, which is also called an atomistic firm, a very small firm, because this firm is so small as compared to the overall market that it does not matter for the market price of the good that the firms produce, whether one such firm supplies more or less of this particular good. So the single firm is a price taker in this setting, and this means that we have perfect competition. So the firms take the market price as given. In such a setting, one can typically derive the results by just focusing on one single representative firm, which then allows to circumvent all types of complications that arise in the context of aggregation. So if we treat many different firms, we would have to aggregate over all of these firms to come up with aggregate employment and the aggregate capital stock in the economy and so on and so forth. But if these conditions here are fulfilled, we can just assume that the production side of the economy is represented by one single representative firm that, however, does not have any market power. This assumption is typically innocuous as long as firms face the same productivity levels, similar institutional settings, and so on and so forth. And then the representative firm is assumed to choose employment of labor, L, and rents the capital stock K so as to maximize its profit. So it employs as many workers and as much of the capital stock that its profit is maximized. What does this mean? The profit of the firm is the difference between the revenue and the cost of production. And the revenue, as we will see on the next slide, consists of the price multiplied by the quantity that the firm sells of its output, and the costs of production consist of the outlays for the production factor labor, so the wage bill, and what has to be paid to rent the capital stock K. And the difference between the two is the profit, and this is what the firms maximize, or the representative firm in this context. Now we describe in more detail the revenue of the firm. As I've already said, the revenue is the quantity of goods that the firm sells multiplied by the price that it can charge for this good. And in a macroeconomic context, aggregate output is produced by the single representative firm because there is no other firm that produces anything. So aggregate output is produced by this particular firm and is given by the production function. The production function, as you see in the chapter on production functions, relates output Y to inputs of capital and labor given the state of technology A in the economy. So the output of the representative firm is Y, and that's the quantity that the firm sells. Now what about the price? The price of the good that the firm sells can actually be normalized to 1, and this is due to the law of Walras, because as you know, you can always normalize the price of one good in the economy to 1 and express all the other prices in relation to this price of the so-called numeraire good. Since in such a basic macroeconomic model there is only one good, and this is final output, the final consumption good that all the individuals in the economy consume, we can normalize this price to 1. So what we have then is that the revenue of the firm is given by the quantity, which is the production function, multiplied by the price, which is normalized to 1. So the revenue of the firm is the same as its output. Next, we come to the production costs for the firm. And these consist of two elements. The first is the outlays for wages, or the wage bill. So that's what the firm has to pay its employees. And the second is the outlays for renting capital, where it's basically assumed that firms rent the capital that they need in order to produce from the household side of the economy. This assumption ensures that the firm side of the economy can be solved, or this profit maximization problem of the firms can be solved by a static optimization problem, and we don't need to be concerned with a dynamic optimization problem that we typically have on the consumer side of the economy, as you can see in the chapters on the Ramsey-Cass-Koopmans model, for example. Now, what is the wage bill? The wage bill is the wage rate in the economy multiplied by the number of workers that the firm employs. That's clear because this product is the total outlay for employees that the firm has to pay. What about the capital rental costs? Well, that's the capital rental rate, R. So what it costs me to rent capital from the households times the stock of capital that I employ in terms of machines, production halls, and so on and so forth. And the capital rental rate in turn consists of two parts, where the first one is the interest rate. That's what I have to pay in order to get the capital, plus the rate of depreciation, because machines and buildings and so on, they wear off. And of course, this wearing off, they have to be replaced and so on. That's also a cost to the firm. So the costs of the firm consist of the wage bill and the capital rental costs, basically. So now we are in a position to write down the profit maximization problem of the representative firm. And this representative firm maximizes its profit, which is typically denoted by pi, and is given by the revenue minus cost, by choosing the optimal employment level, L, and the optimal capital stock for production, K. So then the profit function is given by revenue, which is output, production, as I said before, minus the wage bill, minus the outlays for capital. And this is what the firm maximizes, so the difference between the two, by choosing labor and capital. Now recall that the production function is a concave function in employment and in the capital stock. What does this mean? So holding everything else constant, if you increase the number of workers, you can produce more, but the additional amount that you can produce decreases. So holding capital fixed and technology fixed, each additional worker increases output, but each additional worker increases output by less than the previous worker. Intuitively, this is clear. Say you have a factory with 10 machines, but no workers. Then you cannot produce anything. The first worker that you hire increases output quite strongly. And then as you hire more workers, you can operate the second machine, the third machine, and so on and so forth. But once you have, say, 10 workers, you operate all the machines, and increasing employment further may increase output a little bit further because you can introduce shifts and so on, or if one person is tired, you can replace this person by another worker. But if you have many, many workers for the 10 machines, then the additional workers effect would be rather low. And the same holds true with respect to capital. So assume you have 10 workers in the firm and no machines, then buying the first machine or renting the first machine increases output quite a lot. But if you have then 1,000 machines or so for the 10 workers, then the additional effect of each additional machine becomes very low. So this function is concave. Now, we know that this function here is linear in employment, this function here is linear in capital. So if we subtract these two linear functions from a concave function, the result is again a concave function. So the profit function is concave, and then you can look up in the chapter on static optimization that this implies for the maximum that we only need to check the first order conditions. We do not need to check the second order conditions because we know the function is concave. So we know that by if the derivatives fulfill the first order conditions, then this is the maximum. So we do this here. We compute the first order conditions, which are that the derivative of the profit function with respect to employment is equal to 0, and the derivative of the profit function with respect to capital is equal to 0, because in this case we exactly reach the maximum of the function where it becomes flat. If we increase labor a little bit more, the function would become downward sloping again. And if we increase capital a little bit more, the function would also become downward sloping. So profits would decrease by employing more workers or more capital. And at the point where it is equal to 0, the profit is maximized. Now this is the point, as we see here, where the derivative of the production function with respect to labor is equal to the wage rate, because then the difference here between the derivative of the production function with respect to labor and the wage rate is equal to 0. And the same holds, as a similar argument holds true for the capital stock. So the marginal product of capital, which is the derivative, the partial derivative of the production function with respect to capital, has to be equal to the capital rental rate at the profit maximum. What does this mean from an intuitive point of view? It means that firms hire workers until the last worker is exactly able to cover their cost. So an additional worker produces additional output, and as long as the worker produces more in value of output than it costs in terms of wages, the firm would employ more workers. But at some point, the worker would only produce as much more in value of output as its own cost is, and at that point the firm has to stop hiring more workers, because each additional worker would then produce less in terms of value of output than its cost, and from that point onwards the profit would decrease when the firm employs more workers. And a similar argument holds true with respect to machines. The firm would employ or would rent more machines if the additional machine produces more revenue than it costs. And from the point onwards where the costs would be higher than the additional revenue, the firm does not hire or rent any more capital. What does this imply for the factor rewards? Well, I've already said that at the profit maximizing point, we have that wages are paid their marginal product and capital is also paid its marginal product. So the interest rate plus the rate of depreciation is the marginal product of capital. So this basically, that production factors are paid their marginal product, holds in case of perfect competition. If there are monopolies, oligopolies, monopolistic competition where firms produce slightly differentiated goods, or monopsonies where there is power on factor markets. So if a firm in an area is the only employer, for example, then it has a certain market power on the labor market, then this does not need to be the case. In this case, production factors will generally not be rewarded according to their marginal product. However, we now assume that we are in the basic macroeconomic model with perfect competition, and now I present a certain example that comes up rather frequently, and that's the Cobb-Douglas production function and how factor rewards are determined in case of such a Cobb-Douglas production function, where we assume that technology is constant and we normalize it to 1, and output is a function of capital employed. The output elasticity of capital is equal to alpha, and labor with an output elasticity of 1 minus alpha. Now, in case of this Cobb-Douglas production function, we can easily compute the factor rewards. The wage rate is the marginal product of the production factor labor, so we take the derivative of the production function with respect to L. We see this implies that 1 minus alpha comes down from the exponent. The exponent is reduced by minus 1, so we have L to the power of minus alpha here, and K to the power of alpha remains here. So that's the derivative of the production function with respect to employment L, and we can simplify it. So here we have L to the power of minus alpha, and we have K to the power of alpha, but that's the same as writing K divided by L to the power of alpha, because that's here, if we multiply the exponent by minus 1, that's the same as taking 1 over the variable itself here. So then the wage rate would be 1 minus alpha times the ratio of capital to labor to the power of alpha, and we see from the production function that this is basically nothing else than the production function itself divided by L. So this term here is nothing else than the production function divided by L. So we can rewrite this as 1 minus alpha times the production function divided by L. So that's the wage rate, and all three of these expressions you can see used in different macroeconomic models. With respect to the capital rental rate, it's a similar story. So the capital rental rate is the derivative of the production function with respect to capital employment. So if we take this derivative, alpha comes down from the exponent here. The exponent is reduced by -1, so we have k to the power of alpha -1. And here we still have L to the power of 1 minus alpha. We can also rewrite this. That's, again, if we take the exponent of k and multiply it by -1, that's the same as putting the exponent in the denominator and having the same exponent 1 minus alpha for L over k here. So the capital rental rate is alpha times the number of workers divided by the capital stock to the power of 1 minus alpha. And again, we see that this is the same as the production function here divided by capital K. So we can rewrite this as alpha times output divided by K. Now we know all the expressions for the wage rate, the capital rental rate in case of a Cobb-Douglas production function. And what's important here is that wages decline in employment and the capital rental rate declines in the capital stock that is used in production. And why is this the case? The reason is the diminishing marginal product. If you employ more labor or more capital and holding everything else constant, then the marginal product of this production factor decreases. And since the production factor is remunerated according to its marginal product in equilibrium, then also the factor remuneration would decrease. Another important question in this context is what the factor income shares are. So the factor income shares are the shares of the production factor labor in total income and the share of the production factor capital in total income. So how much of aggregate income is earned by the production factor labor versus capital. And here I provide the expressions for the Cobb-Douglas case that we had on the previous slide. The labor income share is defined as the wage rate multiplied by the number of workers in the economy, so that's the wage bill, divided by the GDP of a country. That's then the share of total income that goes to the workers in the economy. Now, here we plug in from the previous slide the wage rate, which was 1 minus alpha times aggregate output divided by L. So that's this expression here. And then we need to multiply by L over Y, which is the same as this term here. So it's immediately clear that the result is 1 minus alpha. So the labor income share in the economy is constant and given by 1 minus the elasticity of output with respect to capital in the Cobb-Douglas case. What about the capital income share? Now that's defined as the capital rental rate multiplied by the amount of capital employed divided by GDP. So that's everything that is earned by the production factor capital divided by total GDP. So now we again plug in. This time we plug in the capital rental rate from the previous slide. That's alpha times Y over K. And then we see we have to multiply by K over Y. So this cancels out again and the result is alpha, which is again clear because we have 1 minus alpha is the labor income share. So alpha needs to be the capital income share if we have these two production factors only. But again, we see, and this is the bottom line, the factor income shares are constant in this Cobb-Douglas case and with perfect competition. So irrespective of what happens in the economy, we have that the labor income share is always constant and the capital income share is always constant, with the former being given by 1 minus alpha and the latter by alpha. So this is also used historically to estimate the elasticity of output with respect to capital and the elasticity of output with respect to labor, because in the United States until the 1980s the labor income share was constant and about 2/3 and the capital income share was constant and about 1/3. So therefore alpha is estimated to be 1/3 and 1 minus alpha is therefore 2/3. So these parameters are typically used in macroeconomic models. However, as I said, this held true until the 1980s and it conforms to one of Kaldor's stylized fact that you know from the chapter on the stylized facts, namely that the factor income shares stay constant. So the share that is paid to capital stays constant and the share that is paid to labor stays constant. However, since the 1980s, actually the capital income share has increased in many countries in the world, or in most countries in the world, and the labor income share has decreased. And economists have tried to make sense of that and explain it, and there are many possible explanations. And one possible explanation is automation, and automation can explain why the labor income share has decreased, because robots are rather good substitutes for workers, but by itself they are capital. So the income that they earn goes to the capital owners while they compete on the labor market with the workers. So automation is one explanation for the decrease in the labor income share, and you can see this in the playlist on automation in different growth models, for example.